Okay. Is it on progress? Is it on? Oh yeah, okay. Right, thank you very much for coming. So today we'll be talking about a topic here named Kubernetes here. So this is our topic, and my name is Achmad Mardiansyah from GLC Networks. Oops. Yeah, so our agenda today, we'll be talking about the oops. Yeah, so this is our agenda. Agenda today. So introduction, and then talking about some prerequisite knowledge, the Kubernetes, and then if we have time, and then we can do the live practice in one of our server, yeah, if time permits. Okay, so let's move on. Oh wow, it's very laggy. This is new. This new keyboard here. Okay, continue. We are GLC, Garden Lintas Cakrawala, and we are based in Bandung. Our areas are training and IT consulting. We are certified partner for MikroTik, Ubiquiti, Linux Foundation. Our products are, one of our products is GLC Radius Manager. Okay, we have a regular event for a webinar like what we are doing today. My name is Achmad, and I'm based in Bandung. Users, many users, Linux users, MikroTik users, Cisco users. What's going on here? Yeah. Sorry, I have a little bit issue here. Okay. Yeah, so if you have LinkedIn account, and then we can connect. So this is our past experience. We were doing installation mostly related to the networking system administration, mostly based on Linux, and then what else? Software programming. Okay, so we provide solution for our customer. Okay, yeah. About the webinar itself, we started since 2010, a long time ago. At the time, there were no Zoom. And then, yeah, we do a webinar since then. And for yourself, I think some of you already introduced yourself. I can see here some are from Gombong. Okay, thank you. Banyumas, South Jakarta. Okay, Jaksel. Yeah. What else? Okay, so please tell me where you are from here, so that we know where you are from. Okay. So the prerequisite that we are talking today is we assume you already know some of these things. Okay, like Linux administrations, virtualizations, and then the container. Okay, so when I'm talking about container, it's not always Docker, but the Docker is one of the container that is very famous nowadays. Okay, so perhaps you need to learn more about the a Docker container. Okay. Moving on. Okay, let's review some prerequisite knowledge. Before we talk about Kubernetes, first we know about there is a concept for virtualization. So we are virtualizing the hardware. So we have two types of VM. We call it, this one is VM. Okay, it's we are virtualizing from the hardware layer. So because we are virtualized from very lowest layer, and then we can run any operating system here. Okay, so yeah, so it's up to us. We can run FreeBSD, Linux, Windows, many stuff on top of that. Okay, so we have two type of VM. So first is type 1 and type 2. Okay, so type 1 is bare metal. So we have hardware. This is physical hardware, and after that we install the hypervisor. For example, VMware ESXi or Proxmox or Hyper-V or whatever. Yeah. So this is hypervisor, and then on top of that we have guest OS. So guest OS can be Linux, can be Windows, can be Mac OS, can be many things. Okay, because the guest OS will see there is a virtualization. There is a hardware that okay, and then they will think that okay, I will install the operating system on this hardware, but actually the hardware is not true. I mean, it's not physical hardware. Okay, it's fake, right? So yeah, while hosted hypervisor, yeah, or type 2. So we already installed the OS like Windows, Linux, and then on top of that we install the hypervisor like VirtualBox, okay, or what else? VMware, okay, VMware player, VMware player, and on top of that we install the guest operating system. That's the virtualization. Okay, so I guess everyone already knows about this concept. Okay, and then there is another concept called container. Okay, so previously we have a virtualization. Okay, here, oops, annotation. So we have virtualization, but this one is container. So we have infrastructures like all the hardwares. So when we talk about infrastructure, means we talk about the infrastructure, the physical things like a CPU, RAM, networking. So those are storage. Okay, so CPU, RAM, storage, and then networking. Okay, and then on top of that, we install the hypervisors and then guest OS, and then on top of guest OS, we run the application. Okay, so like applications like Apache, and then your own applications like your own software, like based on PHP or any other language. Okay, so while containers, we have infrastructure here. You install the operating system, and then you install the container engine, and then on top of that, we install the application, and then this one here is called container. Okay, so this is container, container, container. Okay, so the big difference here is we are eliminating the need of hypervisor. So it means that the application that we built on top has a similar operating system like the host has. Okay, so same operating system. So it means that if the operating system is Linux, so you are running Linux-based applications. Okay, so that's the consequence, but that's okay. Our application is written on PHP, so it doesn't matter. So as long as we have a correct PHP versions, that's fine, no problem. Okay, so yeah, that's how the difference between virtual machine and container. The history of container is like what you can see here. Okay, so in the 60s, 70s, okay, so we have Unix, and then yeah, and then we have a containerization like change root, chroot, and then we have another container here, and then we have a FreeBSD jail, okay, and then 2004 we have a Sun microsystem. At that time, Sun was very one of a player, IT player in the IT world. So they are using Solaris zones, and then Google has let me containerize. Google also have their own container, and then 2007, because container here is good, lots of isolation. So Linux kernel has initiative to set up LXC Linux container. So this is embedded in Linux kernel. And then they have we have Apache Mesos 2013. We have LMCTFY. Let me container that for you. Okay, so it's from Google. And 2013, 16, this is Docker. Okay, so another container. So LXC and Docker is different. Okay, both of them are container but different. And then here we have Kubernetes. So Kubernetes is actually is not container. It is a tools to manage container. Okay, so Kubernetes can manage this. Maybe Kubernetes can also manage the LXC. So yeah, Kubernetes is just a tools or application to manage those containers. Why? Because we have lots of containers. Sometimes we have to, if the container is not many, okay, you have 5 or 10 containers, you can manage them by yourself. But you have, if you have lots of them, and then you need to have for example, to have a way or an application that can help you to manage all of those containers. Okay, and then Kubernetes is one of them. Okay, so of course, so consequently, before we talk about the Kubernetes, we need to understand what the container is. You need to understand what the LXC, okay, and then also Docker, okay, because many applications now are running based on Docker. So Kubernetes can manage those Docker image. Okay. Okay, let's continue. So let's talk about Docker. So this is just a review. So Docker is like what I'm saying. So it's just an application. Sorry, it's just how can I say? It's a container, and then the container contains application. So for example, this one here. Oh, draw. Yeah. So this is one container, and then this is container, and then this is container. Okay, so you are managing the container is similar to like installing something from repository, like Linux repository, CentOS repository, Ubuntu or Debian repository. So as long as you can get access to the internet, you can install those there's a package, right? So if you want to install Apache, you type aptitude or apt get space install space Apache 2, for example, and then the operating system will download the application for you. As simple as that. Okay, so that was Apache. So what about your customized application? So you build your application and in Docker, and then you compile, you put everything inside, and then you push them into a Docker hub. Okay, so if Debian has repository, okay, where you download and update packages from them. Docker also have same concept. They have Docker Hub. Okay, so you can sign up. You can create an account. You can upload your own Docker image. Okay, so and then based on those images, you install something. Based on those images, you deploy those images into servers. Okay, so same concept, but different implementation. So The first is you install the package using apt-get. Okay, so that's is a built-in tool for Debian or Ubuntu. Why I use apt-get? Because most of our system here is based on Debian or Ubuntu. Okay. If you're using CentOS, you will be using Yum, or now you can use DNF. Okay. Yeah. Okay. So with Docker, what you are doing is just install the Docker image, okay, on your server. As simple as that. Okay, easy, right? Okay. Okay, so I think that's all. Yeah, in the previous where can I? Oh, yeah. Sorry, I need to adjust myself with the new configuration on my table here. Okay, so this is Docker ecosystem, like what I said. So you have your own Docker. Okay. Oops, drawing. Oh, it's very, very laggy. Yeah, okay. So this is your host, okay. This is your host, your local server, okay. Or it can be, or maybe, yeah. So this is your own server, your production server, okay. And then you are a developer, okay. So this is, and then, so here's the client, okay. So the client connect to the host. Okay, and then this server has a Docker Docker daemon, and then on top of that they will run containers, which is built from the image. And then where do you get the image? From the Docker registry, like Docker Hub here. Okay, so for you, like a developer, so this is you as a developer, and then this is your dev server. Okay, you're doing something here. Okay, and then you create an image. Okay, Docker image, and then you push into the hub. Okay, and then from the hub, your production team in the production server just pull something from the hub here. So like a Docker pull, and then the image will be downloaded from the hub to the server and then run, and then the client will see your application updated. Okay, so as simple as that. So otherwise, you have to install you have to install Apache here, you have to install PHP, you have to install library, okay, for your application, right? Okay. With Docker, those things here already bundled into a container. Okay, so as simple as that. So I think by using Docker, you can save times for deployment and then managing your application. Okay, so for example, you have where is the annotation? Yeah. Okay, so you have yeah. So this is your container, right? Container, right? And then on top of that, you're running Docker, right? So one way to manage those Docker is called Docker Swarm. Okay, so you have Docker, you have many physical. For example, this is physical server here. Okay, and then inside the physical server you have containers. Okay, so this is container, container. Okay. Yeah, so you want to manage those containers. So if those containers are using Docker, you can use a Docker Swarm. If they are using LXC, and then you will be using other tools or other applications. Okay. All right. So let's continue. Oh, what's happening? Okay. Okay. So let's talk about Kubernetes. So previously you have. So the thing is, you have Docker, you have container, and then the container contains your applications. Okay. So, and then you need to manage those containers. Okay, so these containers contain a certain application. Yeah, application for login, for example, application for changing email, for example, application for forgot emails. Yeah, so usually we have a big application, okay, and then on that application we split them into smaller application, and then we put them into the container. So we have so the way we use Docker usually, so we have a big application, yeah, like Amazon or whatever. So we split those application into smaller application that handles one particular function. So for example, registration, where's the undo? Yeah. So registration, so it's one application and then one URL. Okay, so if you see big application, usually they split the application into sub URL, right? Like reg dot, for example, just example, glcnet.com. Okay, so this one is for this one. Okay, another one application. So that application is used for registration only. And then forgot password dot glc networks.com. Okay, so this is forgot password. Okay, and this is for this one. So we split those applications, big application, into smaller pieces. And then we have a scheduler. Okay, schedule. Okay, schedule. It's another application like sched.glc networks.com. Okay, so this is another application. Okay, so each application will be using one Docker image. Okay, why we split them? Yeah, because we want to achieve higher scalability. Okay, because if we put everything into one big application, and some points, if the user hitting the application a lot, and then it's difficult for us to scale up. Okay, so for example, if there are lots of registration here, we can just focusing on registration. We can increase the capability. Okay, you have CPU, RAM, and then so on and so forth. Okay, so we split big application into smaller application. Okay. Okay, another application here, and then we put each application into Docker. Okay. Up to this point, everyone is clear, right? Okay, so next. And then we manage those Docker with Docker Swarm if we are using Docker. If not, then you use something else. What if I don't want to use Docker Swarm? And then you can use Kubernetes. Okay, so this is the Kubernetes. Okay, so yeah, like what I said, the Kubernetes is not a container. Kubernetes is the one that manages the container. So sometimes I often get asked questions, Docker versus Kubernetes. It's not apple to apple. It's completely different. Okay, so Kubernetes is used to manage Docker. So you cannot doing versus between them. So if you say Docker Swarm versus Kubernetes, well, that one makes sense because both are in the same classification of software. Both of them are used to manage those containers, right? So yeah, that's the I think a bad or appropriate appropriate analogy how you versus them. Okay, so Docker Swarm versus Kubernetes. So it's not like Docker versus Kubernetes. No. Okay, so this is how Kubernetes works. Well, it's similar, but different in some way. Yeah, so with Kubernetes, you have nodes. Okay. And then you have a node here. Okay, and the node contains the container. They call it pod. Okay, and then you have a master node here, which manage those nodes. Okay. Yeah. So yeah. So they're how they manage is by using API. So there's an API here. I mean, yeah, they're using API. So it's like a MikroTik. Yeah, if you are using MikroTik, or for example, if you have Linux server, so one server can manage other Linux server by using API. For example, by using SSH, and then the tools is Ansible. So you are managing other server using that API, application programming interface. And in this case is Linux command or something. But the API here is much more specific. So the API is used to manage the operation of Docker. Okay, so this is how Kubernetes is designed. And yeah, like what I said, if you're doing versus, better if you do versus like this, Docker Swarm versus Kubernetes. So it's not like Docker versus Kubernetes. No. Yeah, if you're doing versus, you're doing like this. So Kubernetes versus Docker Swarm. Yeah, so we have there are many benefits of Kubernetes. It's got auto scaling. There is an active community. Well, in terms of learning, it's quite difficult because it has lots of terminology, and then yeah, the configuration stuff is much more requires more parameters compared to Docker Swarm. Yeah, can overcome constraint of Docker and Docker API. Okay, and then it's more scalable. Okay, so many operations are now using Kubernetes. So this is Kubernetes components. So as I said previously, so we have a master node here, and then there is a command called kubectl. Yeah, sometimes Kubernetes is called K8. Yeah, sometimes we call it This is a abbreviation of Kubernetes. Okay, Kubernetes. Yeah. So yeah, this is the master node. Okay, so it's in a physical computer. Okay, and then here's the server. Okay, and then here's another server. Okay, and then, oh, this is not correct. This is node 1. Okay, true. This is supposed to be node 2. Yeah, this one is wrong. Okay, so this is how it deploys. So this is your clients, and then your client is accessing a website, right? So this one here, so load balancer is like router. Yeah, everyone knows router, right? So over here, there'll be a public IP. Okay. So you're using, the people here are accessing the public IP. So many requests. Okay. And then after that, so this is a router. Okay. After that, and then router has more than one IP addresses, right? So one public IP here, usually this one is private IP. Private IP, okay? And then on server 1 here, this is server 1, this is server 2, physical server. I'm talking about physical server. And then we have an IP here. Okay, and then we have another IP here. Okay, and then this is a local IP, usually private. Local IP, usually private. Well, usually, yeah, private IP, because it's useless. It doesn't matter if you use public IP or, well, technically you can, yeah, you can use public IP, but if you use public IP and then the public IP and then the client accessing your application here using that same public IP that you have inside, and then you'll have a problem. Otherwise, that public IP is belong to you. You can use it any way you like. Okay, so this is how we deploy. So again, I'm trying to get the physical connectivity here. So this is the router. Okay, and then we have a IP here, and of course there will be a switch. Okay, and there will be a switch here as well. Okay, to accommodate the internal networks. Okay, one goes here, another goes here, another goes here. Okay, and then there will be so this server has two interfaces. Yes, there will be another switch here. Okay, connect to this one connect to that. Okay, and then that one connects to this. So there will be a two network here. So this is LAN, and then here's another LAN. Okay. Okay, this is LAN number 1, for example. This is LAN number 2. I have a question here. Is load balancer managed by Kubernetes? No, it's not. Yeah, it's handled by router. Yes, router can be load balancer. So the way load balancer works is usually this is you have an end user, and you have lots of end user here. End user, end user, end user, end user, end user. Let's say this is IP1, IP number 2, IP number 3, IP number 4, IP number 5. Okay, so all of them are coming from here. Okay, are coming to the routers. Okay, and then there are the load balancer says that okay, IP number 1 goes here. IP1. Oh, so crowded. Let me clear up. Okay. So IP number 1 goes here, IP1, IP number 2 goes here, IP number 3 goes here, IP number 4 goes here, IP4, yeah. So this IP are IP address from the customer. Okay, so that's how it works. Okay, so this is how we implement the Kubernetes. Okay, so we have a front end here. Usually, because we have usually 3-tier application, we have the last one here is database. Database usually is a one it's connected to a specialized network. Okay, so this is just a front end. Okay, and then here we have DB server. Okay, so one connector here, another connector there. Yeah, so for example, if you have a Bukalapak or Tokopedia or whatever, so this is you connect to this, load balancer will send to one node. Okay, and then your message is processed, and then it will query the database. So usually the database is dedicated database. So database is not part of the node here. Okay. So database never be put into container. Yeah, because everything will be container, including database. Yes. So what happened when the container is gone? All the database is gone. Uh-oh. No, it's not like that. Okay, usually the database is dedicated here. So that's why you need to have a very, very good database. Yeah, and then those providers, those cloud providers, usually they provide the very good database as well, database service like Amazon. Yeah, you just name it, Amazon, Ali Cloud, Google Cloud, whatever clouds. And then we have also local players here for cloud provider. Yeah, just name it. Okay. Okay, so yeah, that's how it works. So please do not put database into the Docker. No, Docker is just for application, okay? But database is also application. It's running on layer 7. It's called application. Yes, that's true. But database is used for storing the data permanently. Okay, permanently. Okay, so we need to have a very, very strong and then a powerful database server. Okay, and then on top of and then in front of the database, so database usually in the behind, located in the behind here, DB. Okay, so usually this is back, located at the back. So you never have a chance to directly access the database. No, you never. Okay, never expose the database into the internet. No, it's very, very, I would say, stupid question and then dangerous. Never put, oh, okay, I have a database, MySQL, and then you can connect through this directly through this IP address, and then here's the port 3306 MySQL. No, it's not. Okay, what the customer do is you access this load. Actually, well, it doesn't have to be a load balancer. Sometimes, but it depends. Okay, sometimes you can eliminate this load balancer. Okay, so all requests from the customer directly hit the node. Okay, but that's fine. That's fine. Okay. For example, database is or for example the like for example Google. If you dig google.com, Google has several IP address, right? Dig space google.com or dig space facebook.com. Usually they have 2 IP addresses, and then that one kind of a load balancing on the domain DNS level. So for the first request goes to the first IP address. Second request goes to another IP address. Okay, so it can be round robin like that. Okay, I have comments here. Put what's happening? What's happening? What's happening? What's happening? Everything's gone. Can you see the screen? The screen was blank here. Okay, I have comments. Put database server on Docker. No, it's not. It's a bad idea. Next question from Johnny Hidayat. Do you mean between masternode and nodes must be in different network? What if they are in the same network? Yes, technically you can put here in the same network. Yes, you can. But yeah, we recommend to have a different network. Like if you distinguish between database network and application network. Okay, so here it is like this. So you have a server. So this is server. And then the server has multiple interface, correct? Yeah. So you have interface on this. You have another interface on this. You have multiple unit. You have multiple network interface. Okay, and then each interface connects to different networks. Okay, and then you connect here to switch. Okay. Usually in my previous company, they have architecture like this. Okay, so you have a server connect to switch, and then this switch connect to application network, and then this is database network DB, and then this is for backup. Okay, backup network. Why? Because all requests coming from here. Okay, coming from this network, and then that request, that the server will query the database server using different network. Okay, different network interface. So it will not disturb or affected by traffic from here. Okay, so traffic here from the application network and then database network is separated. Okay, and then what happens if the server needs to be backup? Because backup, once you do backup, it can take time and then lots of effort, and then yeah, it takes time. Also can use higher bandwidth. Yeah, so that's why they separate those networks. Okay, so hopefully, so can we combine all of them? Yes, we can. But for the performance consideration, better if you split them. Yeah, of course, by splitting them, you have to spend more money. Yes, but yeah, but in order to achieve higher performance, better if you split them. Okay, so that yeah, because if you're using the same interface for handling custom requests, same interface for querying database, there will be a queue. There will be interrupt there. Okay, because you have a very limited time for a context switching in terms of operating system. Okay, so better if you split the network. Okay, so yeah, that's my comments on your questions, Johnny Hidayat. From Dwi Chandra, is it better to have two master and then add one server for HA proxy for two master? Sorry, I don't understand this one. Yeah, so this is master. Okay, yes, this is master. Okay, what happened? Master is down. Okay, so you have another backup. Yeah. Okay, so multiple master. Okay, manage those servers. Yes, that could be achievable. Okay. Yeah, that's master, and then Yeah, you can do more than one master for Kubernetes. Okay, yeah. Okay, let me where is the screen here? Oh, okay. Yeah. Sorry guys, I need to adjust myself with the new settings here. Usually the screen is on here, so next to the next screen, but now it's in front of me. So yeah, it's a completely new configuration today. Okay, it goes off again. Sorry. Oops. Yeah. Okay, Salman, how do we do the sizing of the Kubernetes nodes from the number of nodes and then the resources? Well, yeah, it's a tricky question. Yeah, because when we buy a server, a physical server, we cannot. Usually, we buy in bulk, right? Later on, we upgrade the RAM, we upgrade the CPU, so on and so forth. So, how do we sizing? Yeah, it's a good questions. Well, that depends on the requirements. That depends. At least you need to have a test to check how much memory, RAM, and then for example traffic, yeah, or bandwidth does the one request is required is need. Okay, so based on that, you can check. Okay, so for this one, I will need to access to set up to have a virtual to have a server with this kind of specification. Okay, so hopefully that answered the question, Salman. Okay, because I don't have like a calculation or formula how to sizing the calculate the spec of the Kubernetes nodes. Okay, it really depends. I mean, it's just it is of course it's a classic question, classic answer. Sorry for that. That depends. Always depends. Depends. It's very like a sales guy, right? if you talk with the sales guy, they never say uh, they never answer questions directly, right? Usually the answer is always it depends. It depends. Then we will send you quotation. Yeah. Okay, so next to Salman, to be able to activate HA feature, number of masternodes should be an odd number. Yeah. So there will be a like another cluster, architecture. Usually, it's the number has to be odd. Similar like a parliament. Okay, the total number of parliament is odd, not even, because if they are voting, if they do vote, if they are even, so there has to be a winner. Yeah, that's the reason why we need the odd number. Okay, it has to be a winner. It's not win-win. It has to be a winner. Okay, because that's how IT works, right? Yeah. So if you are doing algorithm, well, that's the benefit and then the drawbacks of IT system. Okay, so they always give you one single solution, which is sometimes is correct, sometimes it's not, because not all cases always require one single solutions. Sometimes we need more solutions. I mean, not always one. Okay, a multiple way of doing things. Okay. Okay, so hopefully everyone here agree with the components. And yeah, thank you for the questions. Yeah, it was very fruitful. Move on. Yeah, so this is a Kubernetes cluster. Yeah, Kubernetes requires higher specs in order to be deployed. You can use Minikube, yes. Yeah, for testing how Kubernetes works. But if you implement Kubernetes in the production, usually they doing this way. So you have a master node here, and then you have the node itself. Okay. And then inside the node, you have pod. Okay. And then inside the pod, you have container. Why not just directly to the container? This is the benefit of Kubernetes. Why? Because in the future, how can you guarantee Docker will always last forever? No, it's not. Well, I cannot guarantee the future, but based on the past experience, nothing lasts forever, right? Including Docker. Currently, Docker is very famous, but who can guarantee Docker will always last forever? No. Docker is very famous. Many people using Docker. Yes, correct. 100% true. But no one guarantee that Docker still exists in the future. So instead of accessing the container directly, so the Kubernetes called set an abstraction layer called pod. And then inside the pod, it's a container. Currently, the container is Docker. In the future, they can change to LXC, they can change to something, they can change to something. So you can have same Kubernetes, but different technology of container. Correct? Yeah, so this is the beauty of how, why we use Kubernetes. Yeah, because Kubernetes not only supports Docker, okay, perhaps future technologies, okay, which maybe not Docker, that can be supported by Kubernetes. So yeah, one good thing about Kubernetes is the Kubernetes teams is for how can I say, is anticipating the future. Okay, so I'm not always so they are not always Docker fan. They are not Docker fan. In the future, container can be based on Docker or not. Okay, which was different compared to the Docker Swarm. Okay, for Docker Swarm, here the container has to be Docker. But there are lots of containers out there, like Apache Mesos, LXC, many other containers. Who knows? Okay. So with the Kubernetes, the plan for Kubernetes is to manage those containers. So currently, one dominating one container technology that many people use most is Docker. But that does not mean Docker always be the first choice for everybody. No. So that's why yeah, Kubernetes use this abstraction using pod. So they create the pod first, and then inside the pod you put the containers. Okay, so that's next. Oh yeah, it's done. Well, oh, it's 2030. I think we need to stop today. Yeah, just for a brief explanation about how Kubernetes works. Okay, and then for the live demo, perhaps we can schedule the demo in the future. Okay, anyone agree? So sorry for that. Okay, because we already have 1 hour, and then I have another schedule here for meeting. Yeah, I don't. Yeah. I sorry, I didn't keep up the time. So we're supposed to finish this. I mean, supposed to discuss about Kubernetes earlier so that we can have a time for live practice. Maybe next time. Okay. Okay, guys, so I think that's all. Thank you very much for coming. Okay. And then, yeah, this is a message from admin to have feedback. And then, okay, we have our own website where you can see the schedules. Slides will be available on Slideshare. We usually put the slide over there. Recording will be available on YouTube. Just Googling our channel. And then, yeah, please, if you have time, if you don't mind, please give us a feedback. Okay. I have comments here. Let us know when can we have the live practice. Okay, we'll let you know. Okay. And the last one, oh, okay, photo session. Okay, guys. So I will turn off the share screen. How can I do that? Stop share. Yes. And here we go. Okay, please turn on your camera, guys. We would like to take a picture. Okay. 1, 2, 3. Is it? No. Oh, how to? Is it? Okay, 1, 2, 3. Oh no. Oh, guys, really sorry. Can you can you turn on your cameras here, please? Okay. 1, 2, 3. Is it working? Oops. Oh, that's bad. Shift Command 3. Is it? Yeah. Shift Command 3. Shift Command 4. Shift Command 3. Oh, I really need piece off with this new Shift Command 3, right?
5.
Oh, 5. Okay. All right. Okay. I'm using a new keyboard here and really pissed me off. Okay, so thumbs up. First page, 1, 2, 3. Okay. Next page, 1, 2, 3, and off we go. Well, guys, thank you very much. Sorry for the issue here. Very nice to see you all. And then thank you very much for coming, and see you in the next webinar. Thank you again. Thank you. And then have a nice day. Keep safe.
Thank you, sir.